Okay, so for the part two of our lecture here, so we proceed to example number 3. This is Laguerre polynomials. So we have the given here weight of x equal to e to the negative x, and the sigma of x is equal to x. So the Rodrigues formula for the uh, Laguerre's polynomial is given by this e to the x over n factorial, the n derivative of the product of e to the negative x and x to the n. So we have to compute here L1, so n here is equal to 1. So derivative of e to the x times x to the n is equal to e to the negative x minus x times e to the negative x. So by substitution here, so n here, factorial here is equal to 1 factorial, so that is equal to e to the x. So we have this derivative, first derivative of the e to the x times x to the 1. So we have this, by simplification, we have 1 minus x. So the numerical evaluations here is L1 of 2 is equal to 1 minus 2. Here, x is equal to 2. So 1 minus 2 equal to negative 1. We have the numerical examples here of the Rodrigues rotation formula. Rodrigues rotation formula is given by this. The rotated v is equal to the given vector v cosine of the angle plus the cross product of k and v times the sine of the angle plus k times the dot product of k and v. K here is the axis of rotations. And we have v here, given vector, then multiplied by 1 minus cosine of the angle. So we have a geometrical interpretation of this later on. So, okay, so we have an example for here, rotate a vector about the z-axis. So we have the given here. So the given vector is 1, 0, 0. The coordinates, then the rotation axis equal to k. So along the z-axis, so 0, 0, 1. And the angle is, the given angle is equal to 90 degrees, pi over 2. So cosine of 90 degrees here is equal to 0, and sine of 90 degrees is equal to 1. So we have the cross product of p and v here. 0, 0, 1, that product, cross product with 1, 0, 0 is equal to 0, 1, 0. Then is the cross product of p and v. That product is equal to 0 here. So the rotated vector is 0, 1, 0. So the axis rotates into the y-axis. So we just substitute here in this given formula. So we have the given formula for the Rodrigues rotation formula. So we substitute here. So what we will have is 0, 1, 0 here. So rotate the vector about the y-axis. So we have the given vector here is 1, 1, 0. The axis of rotation is 0, 1, 0. The angle is equal to 60 degrees. So we have the cosine 60 degrees equal to 0.5. Sine 60 degrees equal to square root of 3 over 2. So the axis of rotation is 0, 1, 0. So this is the y-axis. So the cross product of k and v here is 0, 1, 0. Cross product with 1, 1, 0 is equal to 1, 1, negative 1. Then that product of k and v is equal to 1. So by substitution in the Rodrigues rotation formula, so we have this example here. We have to find first the v cosine of the angle, so we substitute here. So what we have here is the 1.707, 0.293 minus negative 1.00. So we have the geometrical interpretation of Rodrigues rotation formula. So let the vector v equal to the vector r, and the vector n is equal to the vector p here. So for example here, the r prime here is equal to the sum of the vector on plus the sum of the vector nv here plus the sum of the vector vq. So the vector to be rotated is r prime here. So this is equal to r prime. So on is equal to r prime. So let on equal to, so our on here is, so this is not It should be, so this one is equal to r prime. This is equal to r prime. So On here is n times the that product of n and r here. So we refer to this the n, the axis of rotations. Then we have the nv here. So nv is equal to, for example, here we first have the np here. So np is equal to the vector r. Vector r is equal to the sum of the vector on and the vector np. So np is equal to r here, vector r minus on. So this is equal to r minus the on here is equal to n times the dot product of n and r. Then we have the cosine. So we have only consider only this part np. So np here is the cosine of the nq here. The cosine of that is just the cosine of that is just equal to np. Then we have the vq here. So the vq here is the cross product of r and n here. Then multiplied by the sine of the angle, because we take only the portion of this. So this part, this is perpendicular to np. So that's equal to r cross product with n and sine of the angle. Then we have to rearrange this to make it the same as the given Rodrigues rotation formula, because this is the one, this is the given Rodrigues rotation formula. So when we arrange these expressions, so it is the same. So this formula is this one. When we arrange this is the same as Rodrigues rotation formula.